Okay, today we're going to look at a problem that we did today in class about how to compute voltage drop. Uh, Basically, voltage drop calculations help us to describe how energy supplied by a voltage source, such as like a battery in this case, is reduced as current moves through all the items that provide resistance in a circuit, whether it be a resistor or a lamp or something to that extent. We want to actually see if I could break it down for you. It's simply how much of my total power goes to this device. How much of the voltage comes here? How much of the voltage comes here? That's what we're trying to find in voltage drop. So I've got the problem that we did today in class, and I wanted to share it with you again so that way you would have it in the event that you're absent today or whatever it may be, so that way you can make sure that you understand this information and how to do the problems. So looking at what I have here, I've got two 12-volt batteries that's powering this series circuit. How do I know it's series? Is because there's only one pathway for electrons to travel. There's not multiple pathways, so all the electrons must go through each one of these resistors, and each resistor has a different resistance. One has 6 ohms, one has 8 ohms, and one has 14 ohms. So to solve this problem, the first step that you want to do is you want to find total resistance. And to do that, we just simply look at our values. In this case, we have 3 resistors, and we want to add that up to get a total resistance. And by doing so, we find out that we have a total resistance of 28 ohms. So I want to write that down right here for you to see. All right, so the first step, if I could describe that and how to solve it, is find total resistance. And again, how do we do that? We added up 6 plus 8 plus 14 to give us 28 ohms. Now, also the next thing we want to look at is down here at the bottom, our total voltage, because this is kind of what we're getting to. We want to make sure that all of our voltages that we compute add up to give us our total whenever we get to the bottom. So if I look at what I have in my problem, I've got two 12-volt batteries for a total of 24 volts. How did I find that? I simply add up the voltages of each of the batteries that are inside the circuit. So in this case, it's 12 plus 12 equals 24. Now, you might not always have to do this. That's why I'm putting a star next to it, just like I told you in class today. Because sometimes there may only be one battery, or they may go ahead and give you the total to start with. So you may not always have to do that, but you're definitely going to need total resistance. Now, the next thing we want to do is now we have to pull in Ohm's law, because if we look at the variables that we now have, we've got resistance and we've got voltage. Now we need to find current. And to do that, we're going to use Ohm's law. All right, to find current. And if you remember from a previous day in class, on the formula sheet that the state gives you, the formula they give you is V is equal to I times R. Now in this case, we're looking for current, so we're going to need to manipulate this formula to get what we want, and we're searching for current, so we would rewrite this as current is equal to voltage divided by resistance. Or if you prefer, I also teach the triangle method. Your triangle is going to have voltage up top with current and resistance that make up the base. And so we can plug in our values that we now have in our problem to solve for current. If we use the algebraic method, it's going to be, in this case, 24 volts divided by 28 ohms. If we use the triangle, we would plug it in as 24 volts over 28 ohms. Either way, we're still solving for current, and we're going to have to divide. So that's what we're going to look at now. We're actually going to find our current by dividing these two, and make sure that you plug it in correctly when you do so. And do 24 volts divided by 28 ohms, and we get a current of 0.857 and more. The more decimals that you write right here for your current, the more accurate your answer is going to be at the end, and you'll see what I'm talking about here in just a second. So I'm going to go ahead and write 0.857. I'm not going to use anything other than 3 decimal places. And the unit for that is amps. Now, the other day when we talked about the difference between series and parallel circuits, it's a very important factor when it comes to current. The current is the same throughout the entire circuit because of the fact that there is only one pathway for electrons to travel. So if we know that bit of information, we can determine that at this resistor in R2 and R3, the current is still going to be 0.857 amps. So where you see I1, I'm referring to the current at resistor 1. I2 is the current at resistor 2, and I3 is the current at resistor 3. We can say that the current at R1 is 0.857 amps. The current at resistor 2 is 0.857 amps, which is also the same at resistor 3. That current is all the same. We're almost done. Now that we know our current, we then, our fourth step is to multiply our current by each individual resistance to calculate voltage drop. Because again, the whole point of this is to figure out how much voltage is being sucked by R1, how much is going to R2, and how much is going to R3. So we're going to do 3 different calculations for this one. So to find the voltage drop at the first resistor, I'm going to multiply current times the resistance, which is 6. So I got 0.857 amps times 6 ohms. Plug that into my calculator. And I get 5.142 volts. Okay? Do the same thing at number 2, 0.857 amps. Multiply that by 8 ohms, and I get a voltage drop of 6.856 volts. And then finally I do it for number 3. This time I'll multiply it by 14. And I get 11.998 volts. Again, where these numbers come from, this is my current, which is the same throughout each one of my resistors. And I pulled the 6 and the 8 and the 14 from my schematic that's over here. Now, if you did this right, the last step, which is always critical to do, is check your answer. By adding all of your voltage drops together. So what I'm going to do is I'm going to check by adding all these 3, and let's see what we get. 5.142 plus 6.856 plus 11.998, and we get 23.996 volts. Now when we look and compare this to our total, which we started by adding these 2 together, it's pretty close. 23.996 would of course round up to 24. And the reason why our answer is not exact is because we rounded when we looked at our current. We didn't use all the decimal places that were provided to us, but we're pretty close. And that's where the discrepancy comes off, is that we rounded our current. If we'd have used more decimal places, we would have gotten a lot closer to 24. But I hope that clears it up on how to solve a voltage drop problem. If you need some additional help, you can always email me and I'll be glad to help you. Thanks.